Welcome back to the Microsoft DP-600 Practice Questions Series. Implementing Analytic Solutions using Microsoft Fabric. This is Episode 5, the second of 3 episodes on DAX and semantic models. Today we focus on performance and query optimization. 14 questions covering aggregations, refresh, storage modes, DirectQuery, and model tuning. Each question gives you 10 seconds. Let's begin. Question 1 of 14. You have a Fabric workspace that contains a DirectQuery semantic model. The model queries a data source that has 500 million rows. A Power BI report named Report 1 uses the model and contains visuals on multiple pages. You need to reduce the query execution time for the visuals on all pages. What are 2 features that you can use? A. User-defined aggregations. B. Automatic aggregation. C. Query caching. D. OneLake integration. You have 10 seconds. The correct answers are A and B. User-defined aggregations and automatic aggregation. User-defined aggregations pre-aggregate specific calculations in the model, cutting the data fetched from the source for each visual. Automatic aggregations let Fabric build and maintain aggregations on large datasets and optimize the query plan. Together, they sharply reduce the data processed at query time. Query caching targets import/live models, not this per-visual DirectQuery path, and OneLake integration writes delta tables. It doesn't speed queries. Question 2 of 14. You have a Fabric tenant that contains 30 CSV files in OneLake, updated daily. You create a Power BI semantic model named Model 1 that uses the CSV files as a source. Configure incremental refresh and publish to a premium capacity. When you refresh Model 1, it fails after running out of resources. What is a possible cause of the failure? A. Query folding is occurring. B. Only refresh complete days is selected. C. XMLA endpoint is set to read only. D. Query folding is not occurring. E. The delta type of the partition column has changed. You have 10 seconds. The correct answer is D. Query folding is not occurring. Incremental refresh relies on query folding, so the date range filters are pushed to the source and only changed partitions are pulled. CSV files can't fold, so the entire dataset is loaded and transformed locally, resource-intensive and prone to running out of memory. That is why the failure points to query folding not occurring. Question 3 of 14. You have a Fabric tenant that uses a Power BI premium capacity. You need to enable scale-out for a semantic model. What should you do first? A. At the semantic model level, set large dataset storage format to off. B. At the tenant level, set create and use metrics to enabled. C. At the semantic model level, set large dataset storage format to on. D. At the tenant level, set data activator to enabled. You have 10 seconds. The correct answer is C. At the semantic model level, set large dataset storage format to on. Semantic model scale-out requires the large dataset storage format to be on for the model. It is the prerequisite that lets read replicas be created. Metrics and data activator are unrelated tenant features, and setting the format off would disable the very capability scale-out depends on. Question 4 of 14. You have a Fabric tenant that contains a semantic model that uses DirectQuery mode. You suspect that some DAX queries load unnecessary columns into memory. You need to identify the frequently used columns that are loaded into memory. What are 2 ways to achieve the goal? A. Use the Analyze in Excel feature. B. Use the VertiPack Analyzer tool. C. Query the $system.discover_storage _table_column_segments DMV. D. Query the discover_memory grant DMV. You have 10 seconds. The correct answers are B and C. Use the VertiPack Analyzer tool and query the $discover_storage_table_column_segments DMV. VertiPack Analyzer reports the internal structure and per-column memory footprint of the model, exposing which columns are resident. The discover_storage_table_column_segments. DMV returns segment-level storage and usage detail per column. Analyze in Excel is a client experience, and discover_memory grant reports query memory grants, not per-column residency. Question 5 of 14. You have an import mode semantic model with a table of 100 million rows that includes fields such as order date time, quantity, total quantity, and total sales amount. You need to reduce the memory used by the model and the time it takes to refresh it. Which two actions should you perform? A. Split order date time into separate date and time columns. B. Replace total quantity with a calculated column. C. Convert quantity into the text data type. D. Replace total sales amount with a measure. You have 10 seconds. The correct answers are A and D. Split order date time into separate date and time columns. And replace total sales amount with a measure. Splitting the high cardinality order date time into separate date and time columns sharply drops distinct values, so VertiPack compresses far better and refreshes faster. Replacing the stored total sales amount column with a measure removes it from memory entirely, since measures compute on demand. A calculated column is still stored, no saving, and converting a number to text worsens compression. Question 6 of 14. You have a Power BI report and a semantic model that uses DirectLake mode. In Power BI desktop you open Performance Analyzer, which shows a DirectQuery metric for the table visual. Use the drop-downs to complete each statement based on the graphic. For each drop-down, choose the correct value. Drop-down 1, the DirectLake fallback behavior is set to Automatic, DirectLake only, DirectQuery only. Drop-down 2, the query for the table visual is executed by using the composite model, DirectLake, DirectQuery. You have 10 seconds. The correct selections are: the DirectLake fallback behavior is set to Automatic. The query for the table visual is executed by using DirectQuery. A DirectQuery entry in Performance Analyzer means the visual's DAX query fell back to DirectQuery. Fallback only happens when it is allowed. The automatic behavior lets DirectLake fall back to DirectQuery when a query cannot be served from DirectLake, whereas DirectLake only would raise an error instead. So the behavior is automatic, and this visual executed via DirectQuery. Question 7 of 14. Report 1 is slow to render, and you suspect an inefficient DAX query. You need to identify the slowest DAX query, then compare how long it spends in the formula engine versus the storage engine. Which 5 actions should you perform in sequence? Arrange these actions in the correct order. View the Query Timings tab. From Performance Analyzer, capture a recording. Sort the duration milliseconds column in descending order. Copy the first, slowest query to DAX Studio. Enable Query Timings and Server Timings, then run the query. View the Server Timings tab. You have 10 seconds. The correct sequence is 1. From Performance Analyzer, capture a recording. 2. Sort the duration, milliseconds column in descending order. 3. Copy the first, slowest query to DAX Studio. 4. Enable query timings and server timings, then run the query. 5. View the Server Timings tab. Performance Analyzer surfaces per visual durations. Sorting by duration finds the slowest. Copying that query into DAX Studio and enabling query plus server timings lets you run it and read the engine split. The Server Timings tab is where Formula Engine versus Storage Engine time is broken out. The Query Timings tab alone would not show the storage engine detail. Question 8 of 14. Report 1 renders slowly. In Performance Analyzer, the visual orders by date is slowest. Its duration breakdown is DAX query equals low, visual display equals low, other equals 1047 milliseconds, the highest. What will provide the greatest reduction in the rendering duration of Report 1? A. Enable automatic page refresh. B. Optimize the DAX query of orders by date by using DAX Studio. C. Change the visual type of orders by date. D. Reduce the number of visuals in Report 1. You have 10 seconds. The correct answer is D. Reduce the number of visuals in Report 1. The other bucket, 1047 milliseconds, dominates, and it captures background work such as waiting on other visuals to finish and general overhead, not the DAX query or visual rendering themselves. The lever that reduces other is cutting how many visuals compete on the page. Optimizing the DAX or changing the visual type would only touch the already small DAX and display portions. Question 9 of 14. The two largest columns in Model 1 are transaction key and sale date time. You must reduce the model size, increase refresh performance in import mode, and ensure the date time value for each sales transaction stays available. What should you do for each column? For each dropdown, choose the correct value. Dropdown 1, transaction key. Change the data type of the column, remove the column, truncate the data. Dropdown 2, sale date time. Change the data type of the column, remove the column, truncate the data. You have 10 seconds. The correct selections are transaction key, remove the column, sale date time, change the data type of the column. Transaction key is a high cardinality technical key that no requirement needs. Removing it gives the biggest size and refresh win, since unused high cardinality columns are the worst for compression. Sale date time must stay because the date time has to remain available. So instead of removing it, you change its data type to cut cardinality/precision while keeping a date time value. Truncating data would drop rows and is not appropriate here. Question 10 of 14. You need to deploy a new semantic model from Lakehouse LH1 that supports complex calculated columns with aggregate functions, calculated tables, and MDX user hierarchies, and minimizes page rendering times. How should you configure the model? For each dropdown, choose the correct value. Dropdown 1, Mode, DirectLake, DirectQuery, Import. Dropdown 2, Query caching, capacity default, off, on. You have 10 seconds. The correct selections are Mode, Import, Query caching, on. Only Import mode supports calculated tables, calculated columns using aggregate functions, and MDX user hierarchies. DirectLake does not allow calculated columns/tables and DirectQuery limits MDX. Import also gives the fastest in-memory queries. Turning query caching on caches report query results. further minimizing page rendering times. Question 11 of 14. You have a Fabric workspace that contains multiple semantic models, including Model 1, which is updated by using an XMLA endpoint. You need to increase the speed of the write operations of the XMLA endpoint. What should you do? A. Delete any unused semantic models from Workspace 1. B. Select large semantic model storage format for Workspace 1. C. Configure Model 1 to use the DirectLake storage format. D. Delete any unused columns from Model 1. You have 10 seconds. The correct answer is B. Select large semantic model storage format for Workspace 1. The large semantic model storage format switches the workspace to the enhanced storage engine, which is what accelerates XMLA endpoint write operations such as partition and data writes. Deleting models or columns trims size, but does not change XMLA write throughput. And DirectLake is not written to through the same XMLA import path. Question 12 of 14. Workspace 1 uses the Premium Per User (PPU) license mode and contains Model 1, which has the large semantic model storage format selected. You need imported tables in Model 1 to be written automatically to Delta tables in OneLake. What should you do for Model 1 and Workspace 1? For each dropdown, choose the correct value. Dropdown 1, Model 1, Enable OneLake integration, enable query caching, enable query scale out. Dropdown 2, Workspace 1, change the license mode to Fabric capacity, create a workspace identity, enable OneLake user-delegated SAS tokens. You have 10 seconds. The correct selections are Model 1, Enable OneLake integration. Workspace 1, change the license mode to Fabric capacity. OneLake integration is the feature that exports and import models tables to Delta tables in OneLake, so you enable it on Model 1. Per Microsoft's documentation, it is supported only on Premium P and Fabric F SKUS, not on PPU. Because Workspace 1 is PPU, you must change its license mode to a Fabric capacity for the integration to work. Question 13 of 14. Model 1 contains a fact table with millions of rows of shipment data. You need to enable partitioning to improve the query performance and manageability of Model 1. Which two tools can you use? A. Tabular Editor. B. DAX Studio. C. Microsoft Power or BI Desktop. D. The Microsoft Power or BI Service. E. Microsoft SQL Server Management Studio. SSMS. SRO. You have 10 seconds. The correct answers are A and E. Tabular Editor and Microsoft SQL Server Management Studio, SSMS. Table partitions are a tabular/analysis services modeling construct. Tabular Editor and SSMS both connect to the model through the XMLA endpoint and can create and manage partitions directly. DAX Studio is for query authoring and tuning, and Power BI Desktop and the service do not expose manual partition management. Question 14 of 14. You have a Fabric semantic model named Model 1 that contains a table named Sales. You need to enable incremental refresh for the sales table. What should you do first? A. Move Model 1 to a Premium Per User (PPU) workspace. B. Create parameters in Power Query. C. From Settings, set large semantic model storage format to on. D. Automate the data preparation by using Dataflow Gen 2. You have 10 seconds. The correct answer is B. Create parameters in Power Query. Incremental refresh requires two specifically named Power Query parameters, range start and range end, date time, which define the refresh window. Creating those parameters is the mandatory first step before you can configure the incremental refresh policy. The other options are not prerequisites for setting it up. And that's all 14 questions on DAX performance and query optimization. Drop your score in the comments. How many did you get right out of 14? In Episode 6, we finished the DAX and semantic model series with semantic model design, storage modes, and tooling. Subscribe so you don't miss it. If this helped, please give it a like and share it with anyone preparing for DP-600. See you in Episode 6.